Hi, Richard here from Past That Science. It's been a while since we've done a video, so I just thought I'd do one today on the mother of all questions. Or is it? So have a look at this. We have a three-line system, four wire, so three-line and neutral, that has got an identical impedance on each of the lines. So each line will have an inductance of 40 millihenry and a resistance of 45 ohms. And the question is asking us to work out the phase voltage. So it looks scary on first impressions, but you need to think to yourself, well, what are we being asked to find out? It's the phase voltage, and the phase voltage is the voltage that appears across just one of the lines, one of the loads. So really, we can discount two of the phases and just work on the one. So how are we going to do it? What's the methodology? Well, what are we being asked to find out? We're being asked to find out what the phase voltage is, which was the voltage VP, which is the voltage that appears across those two elements. What information do we have? Well, we have the current, we have the inductance, and we have the resistance, which is fine. So to find the voltage, so we could just kind of use a process similar to Ohm's law. Instead of saying I is V over R, V equals I times R, we just say V is I times Z because it's an AC circuit. So in order to find the impedance, then we need to use that formula, which is R squared plus XL squared square rooted. So we haven't got XL squared or XL, so we have got L. So we should be able to then find the inductive reactance XL, which is 2 pi FL. So the process will be that we need to find the reactance, XL, we need to find the impedance, Z, and then we can work out the current. So it's just a three-stage process. And let's go and do it. So to find the reactance, we're going to use XL is 2 times pi times F times L. So I'm using 2 times pi, value of pi I'm using is 3.142, times 50, which is the supply frequency in hertz, times by L, the inductance in Henry, which is 0.04 or 40 millihenry. And when you pump those into a calculator, you get 12.57 ohms. Next, then, the second step, we can now find the impedance using Z is the square root of R squared plus XL squared. We worked out XL in the previous slide. So the resistance is 45 ohms, so it's 45 squared plus 12.57 squared, all square rooted. Pump those into a calculator and you end up with a impedance of 46.72 ohms. That now allows you to work out what the voltage is. Ohm's law, V is I times Z. Z, of course, because it's AC. We just worked out Z on the previous slide. So the current is 11 amps times 46.72 ohms, which is the impedance we worked out in the previous slide. So that gives you a voltage, phase voltage of 513.94 volts. That is it. The question is done. Now go past that science.